Topic 4, we have word energy and power. So there will be 3 subtopics to be covered. 4.1 word, 4.2 energy and conservations of energy, and 4.3 is power. So we start with 4.1. 4.1 word. How we define words. So in physics, word is defined as the dot product, or we call it as scalar product of two vectors quantity, which is vector force and vector displacement S. So represent in mathematics, W is F dot S. So what is dot product or scalar product? So dot product means we take two vectors, we multiply them together, and we produce a scalar quantity. So this is what we mean by dot product. For example, I have vector A and vector B, whereby the angle between the two vectors is theta. So for vector B, we can resolve it into two perpendicular components. So recall the prior knowledge how we separate a vector into its x direction and y directions. So for the x directions, we are going to have p cos theta, and for the y direction or y component, we are going to have p sin theta. So what is dot product? Dot product actually is referred to the magnitude of one vector times with the magnitude of the projection of second vector on the first vector, whereby we have A dot B is AB cos theta. So if we refer to the equations of dot product, A is the magnitude of vector A. P cos theta, actually you will find out that is represent the component of B, which is in the directions of A. In the directions of A means the component of vector B, which is parallel to A. Okay, so dot product actually is we taking the magnitude of vector A multiplied with the magnitude of component B, which is parallel with A. So that one is what we call dot product. So dot product or scalar product is commutative. In other words, the order of the two vectors is irrelevant. So A dot B is actually equal to B dot A. It doesn't matter which vector comes first. So it should be clear that dot product of force and displacement equal to word W is F dot S. So we are going to have F cos theta multiplied with the magnitude of displacement S. So the F cos theta actually is the force which is parallel to the displacement. So this will be the physical meanings of dot product for word. Word is the product of the magnitude of displacement and the component of force which is in the direction of displacement. So if you refer this diagram, the car is moved through a displacement while a constant force F is acting on it at a particular angle phi to the displacement. So this force we can resolve or we can break it up into two perpendicular components, which is F sin phi and F cos phi. So you will find out that the F cos phi is the component that parallel to the displacement. So these forces will do work on the car. Whereas the force F sin phi is perpendicular to the displacements. So these forces will thus no work on the car. So we can draw a conclusions. The work done on an object by a constant force F is given by W equal to Fs cos theta, whereby the F is referred to the magnitude of the force, S is referred to the magnitude of displacement, theta is the angle between the force F and the displacement S. Okay? So when the force point in the same direction as displacement, then we will have angle equal to 0 degree, and the equation above will reduce to W equal to Fs, whereby this is the equation that you used before in secondary school to calculate work. So please bear in mind the definition of work take into account only the component of forces that in the directions of displacement. The force which is perpendicular to displacement does no work on the object. So work is a scalar quantity. The SI unit for work is Newton meter or joule, J. So 1 joule can be defined as the work done by a force of 1 Newton, which result in a displacement of 1 meter in the direction of force. So if you apply a force of 1 Newton and the object have a displacement of 1 meter in the direction of force, then we might say that the object have work equal to 1 joule. So because work is a scalar quantity, so work do not have any direction. However, it can have positive, 0 or negative value depending on the angle theta between the vector force and also the displacement. So basically, if the angle between the vector force and displacement is in between 0 and 90 degrees, we will find out that the cos theta will greater than 0. It will give us a positive value for our work. So it means that the work is done on the system by the external force where energy is being transferred to the system. Anyhow, if the angle between the vector F and S is in between 90 and 180 degrees, now we will find out that the value of cos theta will be less than 0, which it will give a negative value for our work. So it will means that the work is being done by the system where energy is being transferred from the system. So I give you the situations here. For example, I have a box and a horizontal force of 5 Newton is applied. Then the box travel a displacement of 10 meter. Then when I do my calculation, so the angle between the force and S is 0. So I will get the work done is 50 Newton meter. Anyhow, for this situation, the angle between the force and the displacement is 60 degrees. So I put it into the equation. I will find out that my work will be positive 25 Newton meter. Then if my force applied now is perpendicular 90 degrees to the displacement, then I'll find out that my work done will be 0 Newton meter. Then if a force of 5 Newton is applied in a direction which the angle between the force and displacement is 120 degrees, then I'll get my work done will become negative, which is negative 25 Newton meter. Then if the object is being displaced forward and the force acting is leftward, so the angle between the force and the displacement is 180, then I'll find out that my work is negative 15 Newton meter. So class, from the example, you can see very clearly the value of work done can be positive, 0 or negative. It much depends on the angle between vector force and also displacement. So this is one of the example if we want to determine work done by each forces. So a person pull 50 kg crane 40 meter along a horizontal floor by a constant force of 100 Newton, which act at 37 degrees as shown in figure below. The floor is rough and exert a friction force 50 Newton backwards. Besides that, because the box is put on a horizontal floor, so there will be normal force acting upward and weight acting downward. So the work done by the pull force F will be Fs cos theta. So we will find out that the angle between the force and the displacement is 37. So I'll get the work done by the force F is 3194.54 Newton meter. How about the work done by the normal force? So if you refer to the diagram, normal force is acting perpendicularly upwards. Anyhow, the displacement vector is pointing to the right. So the angle between the normal force and the displacement is 90 degree. Cos 90 will equal to 0. So the work done by the normal force is 0 Newton meter. Work done by weight will be W as cos theta. So again, the angle between the vector displacement and weight is 90 degrees. So the work done by the weight is 0. How about the work done by the friction force? So the vector displacement is to the right, the friction force is acting to the left. So the angle between the vector friction force and the displacement is 180. So this will give us the work done by the friction is negative 2000 Newton meter. So class, for the first situations, the person is holding a briefcase, does no work on it. Why? Because there is no motion. For this second case, we will find out that a person is moving the briefcase horizontally at a constant speed. The force F does no work on it because the angle between the force and the displacement is 90 degrees. The force is perpendicular to the S. Then for the third case, for case C, when the briefcase is lower, the work done on the briefcase by the generator is negative because the direction of force and the displacement is in opposite directions. So the angle between them is 180 degrees. So cos 180 will equal to negative 1. So bear in mind, the work done by forces that oppose the direction of motion, such as friction, will always be negative. If there is more than one force acting on a body, then we can calculate what we call total or net work. So the total or net work is defined as work done by all the forces acting on the body or the scalar summations of all those quantity of work. So for example, for these situations, so the total work done will be the work done by the first force plus with the work done by the second force plus with the work done by third force, fourth force, fifth, sixth and seventh. The total work done can also calculate by calculating the net force acting on the object and then multiplied with the displacement vector. Then class, we might also calculate work done from a force displacement graph. If you are given a force displacement graph, you might calculate the work done whereby the work done is equal to the area under the force displacement graph. So you might try to do your tutorial for question 1 to question 5 by applying the concept of work that we already discussed just now.